So today we are going to be proving a nice math formula related to the coordinate geometry. We take the Cartesian plane and on this we draw a line whose equation is ax plus by plus c equals to 0. Now we take a random point on this plane whose coordinates are p, q. Now here comes the formula. The perpendicular distance of this point from the line is given by modulus of ap plus bq plus c divided by square root of a square plus b square. You can see that the perpendicular distance of the point from the line can be expressed easily in terms of the coordinate of the point and the coefficient present in the equation of the line. And the reason we put the modulus in this formula is because it ultimately gives us the distance and it should always be positive. So this is Anmol and now let us see the solution. How can we prove this formula? Okay, now let us start with the solution. So the first thing that we can notice over here is that the distance d is special because it is a perpendicular from a point to a line whose equation is this thing. Now we know this thing in coordinate geometry. If we take the axis and then we have two line segment, one is like this way and the other is like this way, and they meet each other as 90 degree. The slope of one of the line segment is m1 and the slope of the second line is m2. Then product of m1 and m2 is equals to -1. This is a very basic thing and can be easily proved. Okay. Now the same concept we will use over here. Now we can say that to fulfill this formula what we need is slope of both of the lines. Now we know the slope formula also if on the coordinate plane we have a line segment and on this line one of the point is x, y and the other point is a, b. Then the slope of this particular line is given by y minus b divided by x minus a. This is the slope of this particular line. Okay. Now this formula and this formula we will utilize first of all. So what I can see is that we have this orange line. Now in order to get the slope of this orange line, what I need is coordinate of 2 points on this line. So I will take the coordinate of this particular point as x1, 0, y0 because this point lie on the x-axis, therefore the value of y becomes 0. Similarly, I will take the other point as this one and the coordinate of this one I will take as 0, y1. Okay. Now there is a very simple thing to be observed over here. These two coordinates lie on this particular orange line whose equation is this thing. The coordinates of this particular point will satisfy this equation. So if I put this particular coordinate, the equation will turn out to be b y1 plus c equals to 0. And if I put this coordinate, the equation will give me an output ax1 plus c equals to 0. Okay. What we did is we simply took 2 points on this particular orange line and gave them coordinate 0, y1, x1, 0. Now we know this particular fact, the coordinates of the point on the line will satisfy its equation. Using that thing, I have obtained this two equation. Okay. Now let us write down the slope of this orange line and I will take it as m1. Now as per the slope formula, the slope of this orange line will turn out to be y1 minus 0 divided by 0 minus x1 and this thing is ultimately negative y1 upon x1. Okay. Now what I can see over here is that y1 and x1 are the variables that we have put from our side. So it's better if we can exclude these variables. So for that I will use this equation. Look carefully. From this first equation I can get the value of y1 that would be negative c upon b, and similarly from this second equation I can get the value of x1 that would be negative c upon a. Now these variables a, b and c were the variables that was already given in the question. So that would be a more better thing than carrying on y1 and x1. So putting that value, so negative c upon b divided by negative c upon a and all this thing again negative. So finally the slope of the orange line that we are denoting as m1 will turn out to be negative a upon b. So this is an important equation and I will label it as the equation number 1. Okay. Now let me just make this diagram a bit more clear. So we have already found the slope of this orange line that we are denoting as m1. Now let us try to find the slope of this green line. Now on the green line one of the coordinate is already given, that is p, q, and that is very important. What about the second coordinate? So the second coordinate that we will take will resemble a very important point and the coordinate I will take is of this particular point where the perpendicular is meeting the orange line. So let me change the color. So I will take the coordinate of this particular point as a comma b. Okay, now we have this green line, and on this green line we have 2 points whose coordinates are given. Therefore the slope of the green line that I will take as m2 will turn out to be q minus p divided by p minus a. This is the slope of the green line, and recall the slope of the orange line, that was m1, and it was equals to negative a upon b. So here we have got the slope of both of the line. Now let us put this thing in this particular formula, that if there are two lines that are perpendicular to each other, the product of their slope will be negative 1. So over here I will multiply these two slopes, as these two lines are meeting each other at 90 degree. So negative a upon b multiplied with q minus p divided by p minus a, and this thing equals to negative 1. Now simplifying this thing will give me the value of q minus p equals to b multiplied with p minus a divided by a, and this is one of the way in which we can write the simplification form. So I will just label this thing as equation number 2, as we have already got the equation number 1 previously. And again I will simplify this thing, and this time I will write it like this way. I will open the brackets also. So aq minus ab equals to bp minus ba, and I will keep this equation as the equation number 3. Now just forget about this particular equation, we will utilize it a bit later on. Just now look carefully on this equation. This equation is not beautiful because in this we have the variables small b and the small a, and these are the variables that we have kept from our side. So as I told you, excluding the external variables that we have kept from our side is the best way to solve a question. So in order to get rid of this, first of all what I will do is I will take this particular equation and write down the value of small b in terms of rest of the thing. So when you will solve this equation, in order to get the value of small b, it will turn out to be a times q minus b times p plus b times small a divided by a. So here we have got the value of small b in terms of a, q, b and small a. Now you might be thinking that this is a nice equation, but it is not, because we have got the value of small b and it is in terms of a, q, b and p, and that were the variables that were already given in the question. But still the variable small a is present, and this is the variable that we have kept from our side. So we have to get rid of this thing also. So what I can see over here that is still missing, the fact that we have still not utilized, is that the point a comma b lies on this orange line. These are the coordinates of this particular point where the perpendicular is meeting the orange line. So ultimately this will lie on the orange line. If this lie on the orange line, it will also satisfy this particular equation. So when I put this coordinates value in that equation, the equation will turn out to be capital A small a plus capital B small b plus c equals to 0. Okay. Now here we have got this particular equation, and what I will do is I will simply put this value of b that we have got in this particular equation. Therefore the new equation that we have just obtained will turn out to be capital A small a plus capital B multiplied with a times q minus b times p plus b times a divided by a, the bracket closed, plus c equals to 0. Now if I solve this particular equation, I will get a square a plus b a q minus b square p plus b square a plus ac equals to 0. Okay. Now using this equation, I can get the value of small a in terms of the variable that were already given in the question. So by doing so, the value of a will turn out to be, okay, so here we have utilized each and everything related to this diagram. Now let us utilize the final thing that will give us the answer, and that is the distance formula. Look carefully. This question is all about finding the distance of this green line, and that is given by this particular equation. So after getting so many equations and doing so much things, we have still not got the distance. And to get the distance, we need the distance formula. So the distance d is between this and this particular point, and the distance formula is the most basic thing. That is, the distance of that green line will be given by square root of p minus a the complete square plus q minus b the complete square. Okay. Now in this equation, we ultimately have the value of q minus p in terms of p minus a. So this value I will replace in this equation. So I will get this particular thing as square root of p minus a the complete square plus, now q minus p is getting square, so its value will also get square, therefore b square into p minus a the complete square upon a square. Simplifying this thing will give me p minus a multiplied with square root of a square plus b square divided by single a. Now recall that we have got the value of a in terms of the variables that were strictly given in the question. So I will replace that value over here. So this thing will turn out to be p minus b square p minus ac minus baq divided by a square plus b square. This thing getting multiplied with square root of a square plus b square divided by a. Now in the next step, first of all, what I will do is I will take the LCM. Therefore a square p plus b square p minus b square p. Now because of this negative, we have to change the sign inside. Therefore positive ac positive baq. This thing getting divided with a square plus b square multiplied with. Now in this second bracket, I will do the rationalization work. So I will get numerator will turn out to be a square plus b square divided by a times the square root of a square plus b square. Now a square plus b square, a square plus b square got cancelled out. Here in this numerator, we can see that positive b square p, negative b square p got cancelled out. Now the remaining terms are a square p, ac, baq. I can take a single a common and factor out that thing with this one. So I will finally get the value of distance d equals to ap plus bq plus c, and this thing divided by square root of a square plus b square. And as d is denoting a distance, the value should always be positive, hence we put a modular sign over here, and this is the answer that we were looking for. So this was my way to prove this particular theorem. If you have any other way other than this, do comment below, and if it's hard to comment, you can email me or else you can send it to me on my Instagram. The link is in the description.